Hello developers. Today we are going to build a deepfake detection engine. By the end of this video, you will have a working model that you can customize and use in your own projects. We'll be using a Kandi kit to build this solution. Now what is a Kandi kit? Kandi one-click install kit gives you ready-to-deploy solution with a complete source code. You can access many more such ready-to-use Kandi kits on augmented reality, artificial intelligence, blockchain, gaming, and many more on Kandi. Today we'll be using a popular Kandi kit which is Deepfake Detection One-Click Install Kit. Now this kit is open source and comes with a permissive license. That means you can freely edit, customize and share your own solution. Let's get started then. Over to you Pooja for a hands-on walkthrough.
Hello, hope you are excited to build your own deepfake detection engine using the popular FaceNet PyTorch library. It has various face recognition models. Today we will use two of its pre-trained models. First, MTCNN, which is your multitask cascaded convolutional networks for face detection and alignment. And second, we will use Inception ResNet V1 for detecting whether an image is fake or real. Over the next few minutes, we will cover three key aspects in this video. First, download and installation of the kit. Second, a simple code snippet exercise. Third, demonstration of the working solution. Let's start by installing the kit. Check the description for the link to the installable. This will set up a working sandbox application with all the needed prerequisites and resources. You can check out these deployment instructions here, and we can start setting the kit by clicking on this one-click installer. This will download a zip file onto your local system. On your local systems, extract the folder. Within this folder, you will get a batch file. Double-click the batch file. Say more info, run anyway. This will begin the installation process onto your systems. Once all the dependencies are successfully installed, you will see this screen wherein you will have all the dependencies set up, repo installed and extracted. So it will ask you to run the kit. Let's say yes, and go ahead. This will open a Jupyter notebook in front of you all. So before we go ahead and discuss the concepts of our solution today, I will augment our knowledge with a simple coding exercise. So for that, I'll open a new notebook. And we can quickly go to kandi.openweaver.com. So this lets you search for interesting functions and code snippets to jumpstart your application development. So here I'll make a search of resize image using OpenCV and hit find. Here I'll look for code snippets. I will have multiple such results and I can choose any of the code snippet which I feel is relevant. So I'll copy this one, get back to my Jupyter notebook, copy this code here. Let's get an image that we would like to resize. So for that, I'll just pick one from the downloads folder. Let's say this, copy it into my C Kandi kits, deepfake detection within the folder where I'm running this current Jupyter notebook. After I have successfully copied that file here, this is a PNG file. I'll get back to my notebook. The name is testing.png. Now I can run my file, Control Enter. So the code ran successfully. Now when I go to that same folder, I'll show you both the images. One is your testing, which is this big, and then out, which will be a smaller resized image, depending on the parameters that you have clearly mentioned here. to factor it with the maximum width and height mentioned here. So now let's move to our understanding of the solution source. So first of all, we have imported all the essential libraries such as Gradio for the interface that we will use to display whether the image is real or fake. Then torch.neural-network.functional SF. This is for interpolation of the image. Then this is the most important facenet underscore PyTorch, which has both the models MTCNN and the Inception ResNet V1. So we load the models imported from here. Then NumPy is used. From Pillow we are importing the image so that we can read the image in any format. And then you have your GradCam, which is used for masking overlay over the image, basically identifying the region in the image wherein the classification of it being fake or real will be done. So these are also all the essential libraries that are being imported. Next step, we load the model either from if your GPU is available, then we use CUDA initialized to 0, else the CPU will be used for that. And then within the MTCNN, we have either to select the largest or post-process as an option. So we have set these two parameters to false. And then the third option is whether which device is being used, GPU or a CPU. So we have the device variable being initialized with that parameter. Further, we have set it to device. So we have set the model over the device and then also set it in the evaluation mode for training. So basically the first model is being used to train or let's say being loaded onto the device. Then comes in your second model, which is your Inception ResNet V1. This has your VGG phase 2 dataset pre-trained already. We want to do classification of our image, so we have set it to true. Number of classes equal to 1 because we just want to classify it either as real or fake. And then the device is obviously set to the device variable. Also, we have this checkpoint wherein we are loading the weights of this model. After that, we are again setting the model onto the device as well as setting it into the evaluation mode. Here is the prediction part where the input image is being passed to this predict method. And then further, we first check or pass it through the first MTCNN model for prediction, wherein our if a face within the image is not detected, then an exception is being raised for no face detection. Further, we convert this or we interpolate this image's face into a 256 cross 256 size in the bilinear interpolation mode. Then after interpolating the face within the image, we are then converting into a NumPy array so that a heat map for the same can be created and analysis could be done. Further, your model is being loaded and checked that if it is being if a GPU is available, else it will be working with the CPU. So this GradCam, when we implement it on the layers, it actually comes out with a classifier output. And how does it do? It does masking over the image, and with the drawing of the heat map, it tries to identify whether the image is fake or real. So first conversion happens into the tensor, and those tensors are then converted into this NumPy array. So all this visualization face image to plot happens. Then further here, after being converted, the prediction is being checked for either being real or fake depending on the value. If the prediction value is less than 0.5, then it is real. If it is greater, then it is fake. So the confidence score is also similarly put down here based on the prediction values of the outcome. The output of this function, your predict, is your confidence score and that face with the masking overlay. So that is there. This is just to get this Gradio interface that you see at the bottom. This codes help you set these labels. Now let's check this solution by dropping an image and seeing how it can help us identify an image even in a news article being real or fake. So this is an example folder that I have created with images from news articles that I have collected from CNN, etc. So an image of Pope with white jacket. I'll upload this, submit it to the solution, and let's see how the model responds. And the amazing part is with 100% probability, our model is able to state that this image is fake. Also, let's try another image. So this is Mark Zuckerberg on a ramp. And even this image, let's submit and see how well our model is able to respond. So then this is the areas, etc. after doing the masking with which our model is able to clearly state that in fact this image is fake. So look at the power of the model. It is able to determine such images which had appeared in news articles when they, were trying to spread fake news about these very, essential people can be clearly determined. Also, let's clear this up and see. Also, you can go ahead and test within the model. If you check, there are some examples that I have particularly put with frames, which is fake frame, and there are some real frames as well. So let's say I pick up this real frame and upload and submit as images. So then for a real image, it is able to clearly state it as real. So I hope this was helpful, and this model will be something interesting that you would like to, work around yourself. Thank you.
Hope you found this session useful. Using Kandi kits is a great way to build AI engines. You can find the link to Deepfake Detection Kit and many other ready to deploy kits in the description of this video. Head over to Kandi to build incredible projects on augmented reality, artificial intelligence, blockchain, gaming, and many more. Try out Kandi kits now. Hit that subscribe button and join us at the OpenViewer community of developers to learn more and build many more incredible projects. Thank you for watching this session. Till the next one, bye-bye.